Hello everyone and welcome back to NotesNaka. From this video onwards, we are gonna talk about basic pixel relationship in DIP. So there are two different types of neighbors, and they are 4 neighbors and 8 neighbors. And before that, what is neighbors? So neighbors are basically all the pixels that are surrounding it. So if this is one pixel, then this pixel, this pixel, this, anything that is surrounding it is known as neighbors. So there can be many neighbors of one pixel. So that is basically the same as we say in our daily lives, like we have different homes and different neighbors. So it is basically the same. Everyone around a pixel is known as neighbor. After that, there are two types of neighbors, 4 neighbors and 8 neighbors. First, let's talk about 4 neighbors. So it is represented by N4P, 4 for 4, and P is the pixel of which the neighbors we are trying to indicate. So a pixel P at coordinates x, y has 4 horizontal and vertical neighbors. So basically, if this is the pixel P, then it has 4 neighbors, the vertical and horizontal ones, this, and this. So these are the 4 neighbors of a pixel. Now let's talk about 8 neighbors. So 8 neighbors is represented by N8P, and it includes the 4 neighbors and 4 pixels along the diagonal direction. So if this is the pixel P, then we first indicate our 4 neighbors, that is this, and this, and then all the diagonal neighbors are also counted as neighbors. So this, and this. So all of these are known as 8 neighbors. So this was the concept of neighbors in digital image processing, and all the next topics that we will discuss, which are very much important in DIP, will be based on this thing. So you should know what neighbors are basically. So now let's talk about adjacency of pixels. So adjacency of pixels are of 3 types. They are 4 adjacent, 8 adjacent, and M adjacent. 4, 8, and M. First, let's talk about 4 adjacent. As we go ahead, you will get the idea of the adjacency of pixels. So 4 adjacent, if P and Q are 2 pixels, Q is the adjacent of P if Q is a member of N4P. So if P and Q are 2 pixels, so we have our pixels P and Q. So if P and Q are 2 pixels, then Q is adjacent of P. It is Q will be said to be adjacent of P if Q is the member of N4P. So we find out the N4 neighbors of P, and N4 neighbors of P will be this one and this one. And if Q lies in that N4P, then Q is the adjacent pixel. So Q is an adjacent pixel over here. The next adjacency is 8 adjacent. If P and Q are 2 pixels, then Q is a adjacent of P if Q is the member of N8P. So we know the N8 neighbors. So in this, if we take the example of this one, if this is P and this is Q, then we can say that it is an adjacent, 8 adjacent. This Q is 8 adjacent of P because it lies in the N8 of P. N8 of P is this, and all of the 4 adjacent plus the diagonals. So this does lie in the N8 of P. So it is known as 8 adjacent. Now comes M adjacent. This is quite tricky than other ones. So for M adjacent, first we determine a V, and I mean we declare a V. V is known as the set of gray levels used to define the connectivity. So basically it tells us the gray level that is required to be adjacent. So suppose this is our example, and in this example our V is equal to 1, That means those having 1 will only be considered. And there are two cases. So first, if Q is in N4 of P, then it is directly known as M adjacent. You do not have to check the other case. We have OR over here. And if not, if it is not in N4P, then we will check the second condition, which says Q is in ND of P. ND means the diagonal of P, and the set of N4P intersection of N4Q has no value from the set V. So for example, let's see, if this is our P and this is our Q, then for M adjacent, first of all we will check Q is in N4 of P or not. Since Q is in N4 of P, we can say that they are M adjacent. So now let's remove Q from here and take Q over here. So for this one, if we check, is Q in N4 of P? Q is not in N4 of P. So then we will check the second condition. The second condition is Q is ND of P. First of all, ND of P. So is Q in ND of P? The diagonal of P? Yes, it is in one of the diagonals, so the first condition is met. Now since we have AND over here, both the conditions have to be true, and in these two conditions any one has to be true because we have OR. So the second condition is set of N4P intersection N4Q has no value from the set V. So if we find out N4 of P, we will have 1 0 1 1. We will have 1 0 1 and 1. And of Q, if we find out the value, this is N4 of P, and N4 of Q will be equal to 1 and 1, 1 and 1. So if we take the intersection of both, we will get only 1. So we have 1 as our intersection. So is 1 lying in V? Yes, it is. That means it cannot be M adjacent. But if suppose our V was 0, then that would mean that 1 is not lying in V, so it could be M adjacent. So this is how we solve these type of, and this is the adjacency of pixels. I hope you understood the adjacency of pixels, and we will meet again in the next video where we will be discussing about path. Till then, take care and bye bye.